Good morning and welcome to Mission Control Houston and Space Station Live. Today is all about eye exams, experiments, and express racks on the International Space Station. Here on the ground, the International Space Station Flight Control Team is watching over all of the crew's activities from the International Space Station Flight Control Room. Flight Director Dina Cantella is leading them today, and Lucia McCullough is assisting as Capcom. The Expedition 36 crew is more than halfway through their day, which began at 1 a.m. Central Time. They are Russian Commander Pavel Vinogradov, U.S. flight engineers Chris Cassidy and Karen Nyberg, European Space Agency flight engineer Luca Parmitano, and Russian flight engineers Alexander Misurkin and Fyodor Yurchikhin. Cassidy, Vinogradov, and Misurkin launched into space on March 28th and docked a few hours later, so they now have spent 124 days in space. Nyberg, Parmitano, and Yurchikhin followed in their footsteps on May 28th, so they've now spent 63 days in space and at the station. Together, the crew is currently orbiting 258 miles above the South Pacific Ocean, heading towards the coast of Chile. A good portion of the crew's time on the U.S. side of the space station is being devoted to the eye exams that have been going on this week as part of the ocular health experiment. After taking part in regular eye chart and tonometry exams on Monday and a fundoscope exam yesterday, Nyberg and Parmitano are today enlisting Cassidy's help to perform ultrasounds of their eyes and take blood pressure measurements. This is part of an ongoing experiment aimed at gathering data on how being in space affects astronauts' intracranial pressure and in turn their vision. Meanwhile, on the Russian side of the space station, Commander Vinogradov is working again today to unpack the almost 3 tons of supplies delivered to the station on Saturday by Progress 52, while Misurkin and Yurchikhin work with Nyberg to gather some of the NASA tools they'll be borrowing for their next spacewalk on August 16th. They'll also spend a good deal of time going over the procedures for that spacewalk, which will prepare the station for the arrival of the new multipurpose laboratory module that will be launching to the space station in the future. Nyberg and Parmitano again took part in the reaction self-test today, looking at how fatigue affects their performance, and they'll repeat that test tonight before they go to sleep. And Nyberg also joined Parmitano in an experiment that he's been taking part in all week, the Pro-K experiment, which looks at how changes in an astronaut's diet can decrease their bone loss during long stays in space. Plus, Parmitano did a bit of work with a BCAT experiment, or the binary colloidal alloy test, which is an experiment that looks at how liquids and gases separate in space, as gravity masks the fundamental physics that drive that separation here on Earth. Allows space scientists to get a better look at what is actually going on in that separation. The bulk of Cassidy's time today was spent working on the station's Express Rack 7, which had a failed rack interface controller. Express is actually an acronym for the Expedite the Processing of Experiments for Space Station. And they are refrigerator-sized houses for science experiments in a number of different disciplines. Cassidy devoted about 4 hours of his day today working to rotate the rack away from the space station's wall, as you see him doing here, so that he can replace that failed controller. That's what's going on in space today, and this is Mission Control Houston. As I mentioned, Karen Nyberg and Luca Parmitano have spent some time each day so far this week performing various vision-related tests as part of the new ocular health experiment. That's an effort to gather more data about vision problems that the astronauts sometimes develop during long stays in space. Scientists here on the ground spent about a year developing this study and expect it to last about 4 years in all, but it just kicked off last month when Nyberg and Parmitano became the first participants. The equipment for the experiment was delivered by SpaceX 2 in March, and now the plan is for the crew members to do these exams once a month during their stays at the space station. Scientists have found that about 20% of astronauts living on the space station experience some vision changes over the course of their stay. They describe it as a flattening of the globe of the eye and a swelling of the optic nerve, which causes nearsightedness. The thought is that this is due to the fluid shift that occurs in one's body while they're staying in space. Without gravity to pull it down, more fluid is shifted to the top part of the body, which causes increased pressure in the astronaut's head, and that might be the reason for the flattening of the back of the eye and the swelling of the optic nerve. But the scientists on the ground need more information to be able to confirm that or identify another cause. And it's important that we understand this problem since it tends to get worse the longer an astronaut stays in space, and NASA's planning to send astronauts on longer journeys to more distant destinations in the future. So earlier this week, Nyberg and Parmitano performed a vision exam, much like what we do here on the ground with an eye chart, and also took part in a tonometry exam, which measures the pressure in their eye. Then on Tuesday, they used a fundoscope to give scientists on the ground a look at the inside of their eye, particularly their retina. Today, with Chris Cassidy's help, they're using an ultrasound to give the scientist an actual view inside the eye that will allow them to check for the globe flattening and the other indications. And in addition, they're also taking blood pressure measurements, as there's been some indication that crew members with more elastic blood vessels and therefore lower blood pressure tend to be more protected from problems with their vision. All of this should be very helpful in pinpointing the source of the problem and hopefully identifying countermeasures to take against it for astronauts in space. But it also has some benefits for those of us back home as well. The same information can be applied here on Earth. Flight engineer Karen Nyberg floating through the Destiny laboratory there for just a quick glance. One of the activities on her agenda for the day is to assist her Russian colleagues with gathering some supplies for their upcoming spacewalk. Although there's still some troubleshooting going on to identify the cause of a water leak in one of the U.S. spacesuits that occurred earlier this month. On the Russian side of the station, Alexander Masurkin and Fyodor Yurchikhin are getting ready to go out on their next spacewalk wearing their Russian Orlan spacesuits in just a couple of weeks. That spacewalk is set for August 16th, when they'll be working to get the station ready for a new multi-purpose laboratory module to be delivered. They'll be routing power cables from the Russian segment to the Zarya module, and they'll do some more work to route an Ethernet cable from Zarya to the Poisk module, again all in preparation for the arrival of that multi-purpose laboratory module. In addition, they'll also set up a suite of experiments on the whole of the Poisk multi-purpose logistics module. To get ready for all that today, the two spacewalkers are spending a good deal of time reviewing the procedures and going over the plans for the spacewalk, and then they're also working with Nyberg to gather up some of the U.S. tools they'll be borrowing for that spacewalk. Again, that's scheduled to actually take place on August 16th. Flight engineer Luca Parmitano has been taking part over the course of the week in the Pro-K study, and Karen Nyberg joined him in that experiment today. Pro-K investigates how what an astronaut eats can predict and protect against changes in their bone metabolism while they're in space and once they get back to Earth. NASA studies the effect of spaceflight on bones in several different experiments, but this is actually the first experiment that looks at whether diet can be used as a countermeasure to prevent bone loss. The experiment's proposal is that a decrease in the animal protein to potassium ratio in an astronaut's diet will lead to less loss of bone mineral. During their stay at the station, the crew members who are participating in this experiment go through 5 dietary intake sessions, 5 blood collections, and 5 24-hour urine collections. During the intake sessions, the crew members eat either a high or low ratio of animal protein to potassium for 5 days straight, while taking urine samples every morning when they wake up. On the 4th and 5th day, they also take additional urine samples throughout the day, and then on the 5th day, they add a blood sample to that. Samples are then returned to the Earth for study, and in all, 16 crew members are expected to participate in the study, which started back during the Expedition 21. If it works, this would be a very good countermeasure for astronauts because it doesn't require any extra effort for the crew, just an adjustment to their diet. For today's part of the experiment, Parmitano is now several days into his run of it, while Nyberg is just beginning hers. Luke Parmitano and Karen Nyberg again got straight into work on science experiments this morning when they performed their first reaction self-test for the day as soon as they woke up. They plan to do another just before they go to sleep tonight. That experiment, the full name of it is the Reaction Self-Test Psychometer Vigilance Self-Test on the International Space Station, and it's a 5-minute activity that allows the crew members on the station to monitor the daily effects of fatigue on their performance. The idea is this helps them identify when their performance is degraded by fatigue-related conditions that can occur as a result of living in space. Things like problem sleeping or shifts in the crew's sleep schedules, as well as activities like spacewalks or this week activities such as the arrival of the Progress vehicle that had them working a bit on the weekend. To test that, the crew members perform 5-minute tests before, during, and after their missions. The tests involve the presentation of a series of randomly timed visual stimuli displayed on a laptop. The crew responds to them by pressing buttons on the keyboard, and reaction times are recorded for their presses. The test will hopefully help crew members objectively identify their performance capability and when it's downgraded due to fatigue, which is a high priority for NASA's behavioral health and performance research. In addition, the 5-minute test is derived from an original 10-minute psychometer vigilance test, which could also be used to measure lapses of attention, wake state instability, and impulsivity induced by fatigue and other performance degrading factors here on the Earth.
And Station Huntsville on Space to Ground 2 for Chris and Expresswreck 7.
Go ahead, Burns.
Hey, Chris. Ground is not getting any good power indications on the Expresswreck 7 the laptop. If you would go back and just check all those laptop connections and power switches on the rack, and the laptop power switch is on the F1 panel. Also check the power switch on the Emerald brick, and then if you would turn on the laptop power for us. And Chris, if the procedure were still handy, it's essentially step 4 of the 0.083, 4.083 procedure.
I feel that's complete. The laptop wasn't turned on, so sorry about that. It's on. It's booting up now.
All right, very good. And ground is getting a good indication at this time. And yeah, and Chris also just wanted to let you know as far as missing anything, you didn't.
Can you tell about the health of the brick yet, or do you need the laptop to help you make sure everything's right?
Yeah, Chris, the latter. We need the laptop to confirm that.
Live view here of flight engineer Chris Cassidy inside the Destiny laboratory, where he has been doing quite a bit of work today with the Express Rack 7 that you just heard him discussing with basically the equivalent of the Capcom at the Payload Operations Center at Marshall Space Flight Center in Huntsville, Alabama. Cassidy was doing some repair work on the Express Rack earlier this morning, and team here on the ground just needed him to turn on a laptop so that they could do some diagnostics and determine how that repair went. Another experiment that Luca Parmitano has been devoting some time to today is the binary colloidal alloy test, or BCAT, which is aimed at studying the effect of phase separation on crystal growth. On Earth, gravity causes colloids to settle, and colloids are nanoscale particles dispersed in liquid, and the liquid's called a colloidal suspension. There are lots of examples of that here on Earth, including things like paint and a number of food products. And these solutions have a unique property. The particles will phase separate like oil and water and then self-assemble into crystals that interact strongly with light, such as opals. That phenomena is difficult to study on Earth because gravity causes the particles to sink to the bottom of the solution, but by performing the study in microgravity, scientists can study the growth of much larger structures, which gives them a better view of exactly what's happening. Photographing the experiment in the space station's microgravity will allow the scientists to measure the processes that are occurring. The hope is that improving our understanding of the process will lead to better manufacturing processes and commercial products. It could also make colloidal engineering a reality in the future. In addition to all the science work that's been going on the station today, Luca Parmitano took some time out of his duties to talk with reporters back here on the ground about his stay in space thus far. He was interviewed by the Italian TG1 network earlier this morning, and we're going to replay that interview for you here next on NASA TV. This is Mission Control Houston.
Buongiorno. Sì, ti sento forte e chiaro. Buongiorno, benvenuta a bordo della stazione spaziale.
Benissimo. Allora, cominciamo con poche domande. Ecco, noi dal TG1 vorremmo sapere la passeggiata spaziale, l'emozione, ma anche la seconda passeggiata spaziale il 16 luglio. Era entrata acqua nel casco. Che cosa è successo?
Water came into the helmet. What happened?
Sì, due passeggiate devo dire molto diverse.
Very different.
Le attività extraveicolari sono chiaramente delle attività molto particolari
very specific
che comportano del rischio. La prima
come with some risk. The first on July 9th went really well without any issue,
senza inconvenienti, per
without any inconveniences.
Un'attività extraveicolare
Therefore,
da manuale.
it was very textbook. So we completed all our activities, and we even went beyond with some activities to start the second one right. However, the second one didn't go very well. I brought the helmet here with me to show you what happened on that day.
Questo è il mio casco, il casco che ho indossato durante...
Yeah, explain to us what happened. Yes,
questo è il mio casco.
This is my helmet. I was saying, this is the helmet I was wearing during the spacewalk.
In orbita,
on orbit,
l'aria per poter circolare deve
air to be able to circulate must be forced, so it must be ventilated constantly. From this hole here that you see underneath, maybe you can't see very well, but there's an entrance that brings the air from the vent loop into the helmet. The diffuser is this white part that you see inside the helmet. So air comes into this hole, and then through the diffuser is distributed throughout the helmet so that it can constantly change the air. So we think that some water from the cooling loop somehow went into the vent loop, and through this hole was transported throughout these diffusers behind the white part, and little by little started accumulating behind my head. Because obviously on orbit water doesn't flow, so it simply accumulated in a huge bubble that after a while I felt, also because its temperature was very low. The biggest problem was when, as you can see, the volume inside the helmet is not a lot, so when the volume increased so that it would cover my eyes, nose and ears, that was the worst moment of the whole activity. Your colleague Chris Cassidy said that the incident could have had some dire consequences. Were you afraid, and will you be going out for a third spacewalk?
Sono due domande diverse.
Well, those are two different questions. Let me answer the second one right away. Definitely, I hope to be able to have other extravehicular activities. Obviously, this is my dream and the dream of many astronauts, but at this time, we are busy with troubleshooting the spacesuit and the ones on the ground as well to see if it's a common problem. Once we have resolved this problem, then we will be thinking about other spacewalks. At this point, it's still too early to be able to understand whether that's something that we can do during this increment or whether we need to wait till next time. As far as the emotions that I felt during the those intense phases. It's very hard to describe because it's a lot of emotions all at once. Definitely, at a very basic level, there is fear, because I always say that fear is an instrument. All your instruments can be used for positive or negative. A scalpel in a surgeon's hand can be an instrument of life, but it can also be used to hurt people. So fear has the same value. You can utilize it to heighten your senses, to be able to think on your feet and react more quickly if it's used properly and if we're trained to do so. Fortunately, my training that I received on the ground and in many years in the Italian Air Force as a pilot and then a test pilot, that training was very useful to me, because when I reacted to the emergency, I try to keep calm and to focus on what the possible resolutions were and how to be able to go back even without a lot of visibility. And I also try to think as fast as I could, if water had reached my mouth, how could I have eliminated it so that I didn't drown in the helmet? So talking about what happens on the International Space Station, do you have an idea from there of what's happening on Earth? What questions do you have for the Italians?
Well,
I'm always in contact with the Earth. Fortunately, technology helps us on board of station, and we have internet on board the station, certainly not continuously. And also due to the fact that we're working for the majority of our day. But fortunately, we have the ability to connect and to be able to follow what's happening in Italy and in the world. Of course, I'm very interested in what's happening in Italy. A message for the Italians. I would like to say this to the Italians, to continue to believe in our nation, to continue to believe in our country. It's a little country, but it's a great nation. There is a lot that we can still do and demonstrate to the world that we still have capabilities and that we still have the will to work and to come back. And this is the time to look to the future and research and invest into the future and our youth. So to invest in them, to look to the fields of expertise like engineering, science, physics. Look at these fields with anticipation and faith, so that with optimism we can come out of a moment of crisis that is not just Italian, but it's a worldwide crisis. So my message is just this: to have faith and to be optimistic. Have you received something from Italy with the latest spacecraft that came up, something that you had asked for? Or did you realize that there's something else that you wanted up there on station? The last Progress spacecraft was a spacecraft containing materials for the station, not a lot of items for us astronauts. What we received was a surprise. I don't know if it came from Italy. I don't believe so, but we did receive some fresh fruit and vegetable that here on station, it's an incredible luxury. It's an explosion of colors and scents that we didn't expect. But honestly, aside from my family and my daughters, I'm not really missed anything here on board. Last question. Do you communicate daily with your family? And what did your mom tell you after your spacewalk? Yes, fortunately, once again, thanks to technology, I have the opportunity to utilize an internet phone to be able to communicate with my family. Daily, I call my wife and I speak with my daughters. When I came back from the second extravehicular activity, I immediately called my wife, who had already spoken with my mom. And I tried to tell them simply that everything went fine, that I was fine, which was true. without trying to minimize any of the events, but also without exaggerating them, because it never makes any sense to exaggerate. So simply telling them that there was a malfunction, that I was back and I was fine. And both my mom and my wife are very used to this kind of phone call after many years as a pilot.
Grazie, Luca.
Thank you, Luca.
Grazie a voi, a presto.
Thank you all. See you soon.
And in the second portion of the event, Luca, I would like to speak to you about the experiment you do on board Columbus. So, Luca, I understand you.
With pleasure. Let me put this aside and I'll. I'm ready for the question.
Okay, Luca, so I understand you'll be taking part in a really cool experiment that's called Energy with Mike Hopkins in September. Can you tell me a bit more about it?
Yeah, absolutely. The energy experiment that will start in September, both with me and Mike Hopkins as subject, is assessing the energy requirement for astronauts, especially with the view of a long-duration mission. What we're trying to discover here is, or to assess, is how much energy exactly does an astronaut need to go on a long-duration mission, for example, to the Moon or to Mars. And the idea is that if we can determine the exact quantity, then we can pack the exact amount of food required, and that would be an incredible advantage, both in terms of storage and in economical terms of how much money we would spend in order to send it. And that also equates to how big the spacecraft needs to be.
And so you're eating and drinking special things during this experiment. Can you tell a bit more about it?
That is correct. I will be eating a very specific diet that is contained in this container right here. So this is food that it's been packed already on the ground. It's very specific, and the scientists know exactly the energy content of each specific container. So when I eat this food, the scientists will know exactly how much energy my intake is, and then I'm going to be drinking a specific amount of water that will let the scientists know. It will let the scientists calculate how much of the energy I'm expending, and so they can create an equation where they have an intake and an outtake of energy, and thus come up with a very precise idea of what an astronaut needs to live on orbit.
And I understand also you have been busy sharing your sleep pattern for an experiment called circadian rhythm. What's this experiment about?
Yes, circadian rhythm is a very interesting experiment. The idea is that because on the space station we do not have a regular the alternance of night and day is not regular. It's not like on Earth where we have basically 12 hours of daylight and 12 hours of night. Here on the station we have 16 cycles a day of night and day. So obviously our sleep pattern cannot be affected by those patterns, and we go into an artificial sleep pattern. So this study has a sensor permanently connected to me for 36 hours that measures my temperature, and the temperature is related to the activity of the body. So technically when we're working we have a higher temperature, when we sleep we have a lower temperature, and by collecting this data they are able to determine how my sleep patterns have been affected by living in an environment that is completely alien to what the normal normal human is supposed to be adapted to.
And what can we learn from this experiment? How can we use it on Earth?
Well, I can think of several studies where the results will be applicable. For example, there are several different kinds of areas of jobs that have a very strong impact on how a person is sleep deprived or stressed. For example, medical doctors or people that work in the police, or pilots that have to deal with jet lags and long stretches where they cannot sleep. Well, this study will allow the creation of procedures that protect these people from over fatigue and from situation where a mistake can be made that could have fatal consequences. So as you can see, the impact of this study, even though it could feel like it's a very small study, but the impact is really big.
We're seeing some kind of a ping pong ball bouncing on a screen behind you in Columbus Laboratory. Just behind you, can you tell us a bit more what this is?
Oh, of course. You mean this screen in the background? So that machine is a sound machine. Is a ultrasound machine, a very small ultrasound machine, as big as a laptop. We use it for several experiments. Right now, today we set it up for an experiment called ocular health, where we do ultrasound of the ocular bulb to see how the lack of weight affects the shape of the eye and our vision. But we also use it for another experiment called spinal ultrasound, where we analyze the changes that the weightlessness causes on the spine. Now, this specific experiment has very important ramification on the ground, where until now, in order to diagnose a problem on the spine, we need very expensive machines like MRIs or body scans. Well, thanks to the procedure that we are developing today on the space station on the ground through remote controlling, in the future we will be able to diagnose actually more. In the very near future, we will be able to diagnose problems on the spine using just a very simple and portable ultrasound machine, just like the one you see behind me. And that is going to be very important for remote areas and places where those machines are just not available.
Thank you very much, Luca. That concludes the second portion of the event. Keep up the good work and speak to you soon.
Thank you, Jules. It was a pleasure talking to you as always, and I'll talk to you next time.
Station, this is Houston ACR. That concludes the event. Thank you.
That again was Flight Engineer Luca Parmitano talking earlier this morning with the Italian TG1 network, as well as individuals from his own European Space Agency, about some of the activities that he has been involved in since his stay at the space station began. In particular, you heard him talk about his spacewalk and the problem he experienced with his suit leaking water into his helmet earlier this month. And then also, you got to look at the equipment he and Karen Nyberg will be using today to perform the ultrasounds on their eyes as part of the ocular health experiment they're taking part in. Flight Engineer Chris Cassidy is assisting with those ultrasounds, but besides that, one of the main activities on his agenda for the day is some work with Express Rack number 7 in the Destiny Laboratory that he has been doing some maintenance on. This is some video taken earlier this morning of that work, which he has since completed. We heard him talk a little bit earlier in the hour with some of the Payload Operations Center's team about the laptop for this express rack, giving them a chance to do some diagnostics on it and make sure that the repairs were all good and everything is back to normal with that express rack. Express is actually an acronym of sorts. It stands for Expedite the Processing of Experiments for Space Station Racks. And what it is basically a home for many of the different science experiments that take place on board the International Space Station, particularly ones that don't require a lot of crew interaction. It can support a number of scientific disciplines and provides the experiments with structural interfaces, power, data, cooling, water, and other items needed to operate the experiments in space. There are 8 of these express racks on board the space station, and express rack number 7 was actually one of the last to be delivered. It arrived on mission STS-131 in April of 2010, and after that there was just one more that came up on STS-133 in November of 2010. The first one actually arrived early on in the space station's life, back in April of 2001, and actually 2 came up at that time, and they have all since been put to good use on board the space station. Each one can hold up to 10 small payloads, which gives the total capability of all the express racks together the ability to operate up to 80 experiments. Today, Cassidy was working to replace a rack interface controller that failed. Rack interface controller is one of several of the subsystems that enable experiment operations on the express rack. Some of the others include the express memory unit, the payload Ethernet hub, and the express laptop computer, as well as the rack thermal system and the solid-state power controller module. One other feature that the racks have, however, is the active rack isolation system that is used to absorb some of the vibration that results from the various equipment running on board the space station, as well as things like the astronauts exercising with the weightlifting equipment or the treadmill. All things like that can cause vibration, which disturbs experiments that require the stability, as much stability as they can get in zero gravity. The active rack isolation system isolates them from that vibration and gives the experiments better quality. And all this activity took up about 4 hours. Again, it was Cassidy working to replace a rack interface controller on this express rack number 7, where you see him working here inside the Destiny laboratory. Continuing to see video from earlier today of Cassidy working at Express Rack 7. Here you can get a good look at the actual size of these racks that line the interior of the space station, giving it to the housing for the equipment and science experiments that are used to run the space station and that go on at the space station. Many times to be able to repair these racks, the astronauts have to rotate them away from the wall of the station, which you can see behind Cassidy here. One other experiment that the Expedition 36 crew members had the option of taking part in today is the Crew Earth Observation Program. As they have time, astronauts on the station can take advantage of special opportunities to photograph specific features on the Earth as they fly over. These photographs record the Earth's surface changes over time, as well as dynamic events like floods, storms, fires, and volcanic eruptions. And the images then provide researchers on Earth with key data for better understanding the planet. More than 500,000 photos have been taken from the space station, and Expedition 36 has added several thousand to the store as well. Today, the crew had several opportunities that they could take part in. First, starting with some ice fields in Peru. They were told to look for clusters of ice-capped peaks that form a semicircle around Lake Sibinacoa, and hopefully get some detailed views of those ice caps for use by scientists on the ground. They were also asked to add to the growing collection of photos of capital cities around the Earth for the collection that astronauts have been adding to little by little over time. Today they were going to be flying over La Paz in Bolivia. That's a city about 50 miles southeast of Lake Titicaca and has a population of 1 to 2 million and is the world's highest capital city with an elevation of more than 10,000 feet. They also had a chance to gather photos of polar mesospheric clouds in eastern Asia. Those can be difficult to detect as they are very high altitude and wispy bluish clouds. And they're visible just above the Earth's atmosphere after sunset while they're still illuminated by the sun. It's now the northern hemisphere season for observing such clouds. And the crew actually had 2 different opportunities to try and grab some photographs of them.
45 minutes. And so we agree that in the beginning, we rest 15 minutes, and then after that, we officially proceed to working. That's why we have 6 hours and 35 minutes.
4 is private.
Otherwise, it would be...
Thank you.
Coming now to the end of today's Space Station Live. Coming up next on NASA TV, you'll get a look at some of the other activities going on at NASA centers around the country in the NASA TV video file. That'll begin at 11 a.m. Central Time at the top of the hour here next on NASA TV. And this is Mission Control Houston.